The Cherenkov Telescope Array, named CTA, is an ESRI initiative to build the world's largest and most sensitive ground-based high-energy gamma-ray observatory. The CTA data and their scientific products need to be preserved in a dedicated archive guaranteed to provide open and widespread access to heterogeneous scientific communities. One of the major technological challenges related to the data handling and archiving of such a huge amount of data. This demo is a first prototype of the CTA archive using technologies developed within the INDIGO-DataCloud project. In particular, we are focusing on employing OneData solutions for developing a distributed system deployed as a federation of different storage entities. These storage entities can be included in the logical data grid topology infrastructure as the one used for production of LHC experiments. In the CTA virtual organization, simulations and CTA data reduction will redirect the output to the distributed archive. OneData system virtualizes storage systems provided by storage resource providers distributed globally. A distributed archive allows to lower costs respect to a single huge data center, including easy manageability and maintenance, scalability and disaster recovery thanks to the site's redundancy. The demo infrastructure has been set up using VirtualBox virtual machines, with CentOS 7, and Docker containers for OneData services. These containers can be found at Docker Hub. Helpful information and scripts to run the OneData services can be found on GitHub. This is the CTA One zone where you can sign in using one of your existing accounts. After accessing a new space can be created from the data space management area. Next thing you need is to get support for USpace from one or more providers. For this you will have to send your token to the provider administrators. A space is a virtual directory, which contents are stored in distributed storage resources provisioned by providers. It is possible to add new folders or upload dataset. In this demo we upload dataset coming from the ASTRAY project, which is aimed at building a first prototype of small-sized Cherenkov telescope. The data will be distributed in the two providers named Catania and Rome. In this case the file has been uploaded in the Catania provider, which by now holds all the blocks of the file, and the metadata are also shared in the Rome provider holding no data blocks. The ingested data need to be enriched with metadata. For this purpose, the operations are performed via the Cloud Data Management Interface, named CDMI, or, alternatively, REST API can be used. A client token is needed for performing the CDMI calls, and we exported it as environment variable. It is possible to read the metadata with the following call. These are the file system attribute we can get. We can also write extended metadata to the file, in our case, for example, the origin ID or the observation ID. This extended attributes can be visible from the OneData user interface. Metadata queries are performed using REST API and indexing functions on predefined extended attributes. This is a sample indexing function. And this is a sample query to get the resulting object ID for the dataset. The database managing the metadata is Couchbase, which is embedded in OneData. It contains schema-less description of the data and is suitable to query and retrieve data using elastic search engines such as N1QL or Common MapReduce functions using the standard Couchbase console and SDK. Finally, we show how to connect using one client and the client token. The client is started as Docker container and it is able to mount the user spaces into the local file system at the Mount One client path. Here we see how to attach the One client container and navigate through the user spaces. Thank you for watching. For any questions or comments, feel free to contact us.